Hello everyone, I'm Perihan İşcan from Bilkent University. My department is Electrical and Electronics Engineering, and this is my Physics 101 project. In this project, the simple pendulum was studied. The period of motion was measured by varying the mass of the bulb and the length of the string. The aim was to demonstrate that the mass does not have an impact on the period of motion, whereas the length does. Three different masses, string, a protractor, a stopwatch, a sports stand, measuring tape, scissors, and a mass scale were used in the experiment. The periods were measured and compared with a stopwatch for each mass and string length. First, a 20 cm string was tied to the sports stand, and the smallest mass was attached to the string. Using a protractor, the first mass was released from an angle of 14 degrees, and the time was measured for one complete oscillation. The procedure was repeated for the other two masses, and each period was recorded. Subsequently, the length of the string was decreased to 10 cm, and the measurements were repeated. The length of the rope was increased in 5 cm increments, exceeding 20 cm each time, until a final length of 35 cm was reached. The experimental results were compared with the theoretical values by calculating the error percentage. A graph was constructed for the first table, plotting the squared experimental period on the y-axis against the length, the independent variable, on the x-axis. The data gathered for the 30 grams mass was placed on the graph, and a best fit line was drawn to represent a linear trend. Finally, the slope of this linear graph was extracted. This constant defines the linear rate at which the squared period increases as the pendulum length is extended. To conclude, the results showed that changing the mass did not produce any significant change in the period of oscillation. This indicates that the period is independent of mass. However, increasing the period of the string resulted in an increase in the period. The graph of squared period versus length produced a linear relationship, and the expected physical behavior of a single pendulum was confirmed.